Alright, so in today's tutorial, we'll be looking at introduction to R. And in this tutorial, we'll look at how to actually download and install R and RStudio, how to also use some basic commands in R. So to begin with, R is a free software tool for statistical analysis comprised of the R programming language and the R environment. R is distributed via the comprehensive R archive network, a network of servers around the world from where you can actually download R and its extension packages. You can access it via this link, or if you type this in your web browser, I think it should move you to this page. Then you can just click on this to download it from a particular mirror. You can just choose any of the mirrors. So I'm just going to check this. So you have to look at operating system. I'm dealing with Windows, so I'm gonna check this. Then click on this. Then click on this. Right, so once you click on this, it will download. I've already downloaded it. You can create a folder to download this. Right, so the next is to look at the RStudio. The RStudio is an integrated development environment for R. That is, it is a type of text editor that makes it easy to develop applications in one or more programming languages, such as writing and documenting code, compiling and performing tests. So basically, this is also a free and open source project which can be accessed via this link. So if you click on this or you just type this in your web browser, it should move you to this page. Right, and just click on this free open source license. Then you can also choose just click on this and just click if you are using Windows. If not, and you're using a different operating system, you have to choose the preferred one. Right, so for Windows you can choose this. I've already downloaded this and have them in my folder. So once it's finished installing, you can just run this. The process or the steps are quite easy, right, to follow. So when you're done, you can open your RStudio, which has this interface. Yours will be different from mine because I've actually edited this, or yes, I've actually modified this. So you can actually, if you want to do the same modification as mine, you can just come to Tools and click on Global Options. So it's taking some time to actually open. Okay, so once it opens, you have this Windows. Click on Appearance and just look at the theme that you want to use. So if you want to use the modern type, we have different options. You can choose the preferred one. Right. You can also look at the font size, the zoom in. You can look at the edit theme. Right, I'm using the Cobalt. You can choose any edit theme of your choice. Right, so this is how you can also modify your interface. So I'm gonna cancel this. Alright, so we have basically 4 panels when you open your RStudio. We have the source editor, where you can actually type all your codes to be stored for future use. We'll be making use of this in our subsequent tutorials. We also have the R console, right? This place you can just execute commands straight away. And in this, you have your environment and history, where most of the commands that you'll be executing will be stored for future use. And also you have the package and plot panel, where you can install and update some packages. And you also have the plots, where you can plot and view some information, where you can actually export most of the graphics that you plot. Right. Then you also have the help button here. If you need any information about R, you can just type in here. For instance, linear models, it gives you information about the a function, then you can read to know more about it, right? So let me bring it down. So these are the four main panels, but we'll be making use of the R console in this tutorial. So let me pull it up. Right. So let's go back to our slide. So in this tutorial, we'll be looking at some numbers, starting with real numbers, right? We know that you have two types of real numbers, the rational and irrational. Right, so rational numbers can be expressed in this form, right? Those that can be expressed as a quotient of two integers, right? So how do we code this in R? So we're using the R console. So I just have to use 1/4 to have the result shown below. So that's it, right? You can also have the next one was 5 divided by 2, right, which was 2.5. So this is quite easy to do, to actually start with, right? So that's with rational numbers. Let's look at irrational numbers. This is the opposite to rational numbers, right? So let's look at pi and square root of 2. We have pi, right, and we have square root of 2, square root sqrt 2, right? So this basically is going to give us the results, right? So this basically giving us the result for and the rational number pi. And one thing that you have to note here is that all these executions that we are operating this panel can actually be seen in the history, right? It's always being stored so that you can retrieve it if you want to go back and actually look at what you did. So, and the environment we can also actually see information here if we assign this value to a particular object. So let's say we want to assign pi to A. So we have pi to A, right? You can use the equality sign as an assignment operator. You can use this as an assignment operator, right? So either using this or the equality sign. I prefer to use the equality sign, right? So just press enter and you see A is being stored as pi, right? So that's the usefulness of this window or panel. So I think we are good to go. Let's look at the next line of action. We have integers. Here we want R to pick the object as an integer and not as a numeric value. So how do we do this in R? So if let's say we assign -29 to B, right? We just press enter. We have this. If you look at the class of B, it says it is this. Let's look at the class of B. -29. Is it going to be an integer or is it going to be a numeric? So let's wait for the results. It's taking some time to, okay, so now we have it numeric. So actually this is not an integer, right? So B has been stored as a numeric, right, and not as an integer, but we want R to recognize B as an integer, so we have to modify this. So B equal to -29, we add L to it, and once we do this and we check for the class of B, it says it's an integer, right? So I think this is how you actually deal with an integer in R, right? Okay, so let's look at the next thing to do. We want to look at complex numbers, right? So how do we do this in R? So we can execute this. Let's start with the first one. Z1 equal to 7 minus 8i, right? We know the real part and the imaginary part. So we just press enter and it's being stored in our environment. We do the same for z2, which was 4 plus 3i, right? It's also being stored. Let's look at the class of this object, z1. I can bring colon, so class of z2 and just press enter. So they are all complex numbers, right? So these are not real numbers. It has recognized this as a complex number because of this imaginary number. So how do we get the real part and the imaginary part? We can use RE to get the real part. So Z1, right? And we can use IM to get the imaginary part of the real number, right? Now we can also look at the conjugates, right? How do we get a conjugate of a complex number? So we use conj, see the pop-up, right? Conj z1, right? So that's it. You can do the same for z2, conj z2, right? So that's a conjugate. All right, so I think we are good to go. So the next is to look at how to run some numbers in R. How do we run numbers in R? Let's look at rounding this digit to the nearest whole number. So we can use round. Actually, this place look a little bit messy. I want to clear everything here, so actually I can use this brush here, which command can be Control L, right? So let me use this brush to clear so that it looks nicer now. So I want to look at round, right? I want to round 7.3825, 7.382592, right? Let me copy this. So let me run this to the nearest whole number. So comma 0, right? This runs it to the nearest whole number. Okay. So let's look at the next is to run this to the two decimal figures, right? Or 2 decimal places. So I can use round. Then I'm gonna use comma 2. This runs it to the 2 decimal figures. Then the next is to run this to 4 significant figures. How do we do this? Let's see. Significant, right? Significant, this, choose. So I'm gonna copy, then comma 4. So this is going to run to the to 4 significant figures, which is going to be 1, 2, 3, 4. So we expect it to be 7.383 here. That's it, right? So the next is to look at the floor of a number, right? This basically runs the digit down. It runs down, right? We are actually looking for the greatest integer that is less than or equal to this value, right? This digits. So we can use the floor and use this, which basically going to run it down. So the integer, the greatest integer is less than or equal to this is actually 7, right? And we can also look at the ceiling of a number, which is basically the opposite of the floor. It's going to run this digit up, right? So let's look at the ceiling of a number. Ceiling. So we have 7 point. Let me type. Yep. So run, and that runs it up. All right, so let's look at the next line of action. We want to look at some basic functions, right? It's like log 5 base 2. Log 5 base 2. Let me clear this using Control L, right? So once everything is being stored in the history, so you can check, right? So that's the importance of this window. So now I want to look at log 5 base 2, right? So log 5 base 2. So just press enter. We can also do the same using log base 2 and 5, right? Get the same results. All right, so the next basic function is the natural log of 3. So just use log 3, right? There's no need for base, so log 3 gives us the results. Then we can also look at the next function, that's exponent minus 0.45 e. We're going to use exp minus 0.45, right? Minus 0.45. So do this, and that's it. The next is 6 factorial, right? So we can do this by typing factorial, right? 6, right? So the next is to look at combination, right? 7 combination 4. So we can do this using choose 7, 4, right? 7 and 4, and that gives us a result. Choose 7 and 4 combination, right? Then we can also look at another transcendental function, cos of pi. Cos pi, right? But this result is in radians. So if you want to change it to degrees, then you have to install a package. You can come to packages and install this package. So you have to install this package NIST unit, this package. You have to install this package, install, right? I've already installed it, so I'm not going to install it again. So once you install this package, you can load it using the library NIST unit. So because I've installed it, it's showing, right? So you just press enter to load. Then we can change this to degrees. So I'm going to use NIST radian, right? Radian to degrees. I'm choosing this. So I want to change this result to degrees. So I'm going to type the same command, cos pi, all right? And this now in degrees. So that's how it works. Once you know this transcendental function cos, you can also look at the other function, other transcendental function sine, right? You can also look at tan, right? How it works. So let's move on. So I want to look at the inverse of the sine inverse function. So we can do this using a sine, right? This is the sine inverse function R. So just type pi, right? Minus pi, right? So that's, and saying this is not applicable, it's not a value, right? The result is not a number. So that's what you see. And so let's use a different digit. Let's say 1, right? We have to know the domain of the sine inverse function. So let's use 1 and enter. So this is actually in radians, right? So if you want to change the degrees, which just use NIST radian to degrees, right? So radian to degrees, then I'll type the same sine inverse function 1 so that I can look at the result in degrees, right? So that's approximately 90 degrees. If you want to change it, if you want to change from degrees to radians, just type NIST degrees, DEG degrees, right, to radian. So you just choose this and put in the value that you want to look at, right? So let me clear everything. The next is to look at the hyperbolic function, right? So you can use tanh, right? And we have pi, right? So that's it. The next function that we can look at, basic function, absolute value of minus pi, right? So use ABS, absolute value minus 5, and we have our results. And the next is to look at square root of 8, right? Square root 8, right? So yeah, I think we are good to go. So this actually an introductory tutorial for beginners in our subsequent or next video. We'll be looking at some data operators in R, right? So I hope you'll stick and stay and watch. Thank you for watching.